Today I'm going to give you a quick tutorial on how to master or learn some factoring techniques that we need to use in algebra. Now, factoring is one of the most important skills that you need to learn in algebra, so answering math problems will be a lot less frustrating. So if you can master factoring, you'll be able to understand and answer math problems a lot easier when you go to calculus or trigonometry or higher algebra. Now, the factoring techniques that I'm going to be using today will be factoring by difference of two squares, factoring using the greatest common factor, factoring by grouping, factoring quadratics wherein a is equal to 1, and factoring using quadratics when the leading term is no longer equal to 1 but greater than 1. So these are the factoring techniques that I'm going to be discussing in this lesson. Now let's work on the first factoring techniques, which is the easiest factoring technique to use because you only need to recognize the difference of two squares in a given polynomial by this pattern. So if you see a squared minus b squared to this pattern, you can factor it out or separate your polynomial into a minus b times a plus b. Now, to be able to understand factoring better, you really need to invest some time on mastering the times table or the multiplication table, because if you can visualize your multiplication table easily, then factoring will not be that frustrating. Now you will see that the perfect squares that I'm talking about here will be 1, 4, 9, 16 up until 144, which means if you take the square root of those numbers, it will give you an integer as an answer. So these are some of the perfect squares that you will see or encounter in this particular factoring technique. Now we have three examples of polynomials that fall under this category. Now notice that problem number 1, 2, and 3 will have 16, 81, 9, and 4, and all of them are perfect squares because if you take the square root of that number, you will get an integer as a result. Now since 1, 2, and 3 matches the pattern a squared minus b squared, we can separate this polynomial using this factored form. So 16 minus x squared can be simplified or can be separated into 4 plus x times 4 minus x, and m squared minus 81 can be factored out into m plus 9 times m minus 9, and the last problem we can separate it as 3y minus 2x 3y minus 2x times 3y plus 2. 3y minus 2 and 3y plus 2. I'm sorry about that. So this is how we use this technique in finding the difference or finding the factored form of the difference of two squares. So once again, you need to know your times table to be able to recognize this pattern. So make sure that you know your multiplication table really well to be able to understand factoring a lot easier. Now the second factoring technique that we're going to be using will be the greatest common factor technique. Now before we use that factoring technique, let's first review on how to find the greatest common factor of a polynomial. So we have 2x plus 4, and the greatest common factor of this polynomial is equal to 2 because 2 is the greatest common factor that can divide 2x and 4. So that's going to be the greatest common factor for problem number 1. And for problem number 2, the greatest common factor is 2 for its coefficient and x for its variable, because 2x can divide 2x squared and 4x evenly. And for the last example, notice that in our coefficient, there is no common number that can divide 15 and 4, which means we'll only have the greatest common factor in the variable. And in this case, the greatest common factor is x squared. So this is how we find the greatest common factor of a given polynomial, which we're going to use in factoring using the greatest common factor. Now let's use the same set of examples that we've used, and this time we'll change it into its factored form. So factoring is basically undoing or reversing the distributive property. So if you can reverse the distributive property, you'll basically factoring using the greatest common factor, which means if we have 2x plus 4 with the greatest common factor of 2, if we divide 2 and 2x to 2x and 4, our quotient will simply be x plus 2, which means the factored form of 2x plus 4 will be 2 times x plus 2. And if we multiply out 2 to x plus 2 or use the distributive property, notice that it will still equal to 2x plus 4 because, as I've mentioned, factoring is simply undoing the distributive property. So if we're going to use that strategy to 2x squared plus 4x with the greatest common factor of 2x, if we divide 2x to 2x squared, you will be left with x. And if you divide 2x to 4x, you are left with 2. So the factored form of 2x squared plus 4x is simply 2x times x plus 2. And for problem number 3, x squared will be outside the parentheses and 15x plus 4 will be inside the parentheses because you have undone your distributive property in factoring using GCF. So that's how we use the greatest common factor for problems 1, 2, and 3. Now, let's discuss 2x squared plus 4x further, just to give you how we can use the greatest common factor in any polynomial that we will encounter in algebra. So, first thing that you need to do is to find the greatest common factor of the integer or the coefficient, and in this case, the greatest common factor of 2 and 4 is 2, and with the variable, the greatest common factor here will be x. So we always want to check the greatest common factor of the integer or the coefficient and the expressions or the variable that we are working on. And once you have found the greatest common factor, just divide the common factor to 2x squared and 4x and you'll have the factored form of your polynomial. So that is how we factor using the greatest common factor. Now we're going to be working on lesson on mastering factoring by grouping. So this is another factoring technique that we're going to be using in algebra. And in this particular example, notice that we'll have a few more terms in our polynomial so we can use this factoring technique. Let's say that our polynomial is y cubed plus 3y squared plus 4y plus 12. Now notice that there's no single factor that can divide each term in this polynomial. So when this happens, we'll use the factoring technique by grouping, which means we're going to separate each group into two sets. We'll have the first set, which is y cubed and 3y squared, and the second set will be 4y plus 12. And since we have separated into two groups, now we can use another factoring technique, which is the factoring techniques that we just learned, which is we will factor out each group using its GCF. Now for the first group, the greatest common factor of the first group is y squared. And the greatest common factor of the second group would be positive 4, which means if we divide y cubed plus 3y squared by y squared, we will be left with y plus 3 inside the parentheses. And for the second group, if we divide each term by positive 4, we will be left with y plus 3 in our parentheses. So now we have two sets of terms with a common factor of y plus 3. So notice that in our first group, we're able to produce y plus 3 as a factor, and the second group, we're also able to produce y plus 3. Now in this case, we'll be able to use the factoring using GCF once again to be able to simplify our polynomial further. So by factoring by grouping, we're using several factoring techniques to be able to solve or to be able to separate our polynomial. So in this case, y plus 3 can be factored out outside the big group, and in the big parentheses, you will be left with y squared and 4. So the completed factored form of this polynomial using factoring by grouping will be y plus 3 times y squared plus 4. So this is how we use the factoring by grouping for polynomials similar to this one. Now let's try this again to our second example, and you will notice that in time by exposing yourself to a lot of examples, you'll be able to do it better and a lot easier, because in mathematics, it's all about practicing and exposing yourself to a lot of problems to be able to understand the steps easily. So let's use this technique to this next set of polynomial. So we have four-term polynomial. Just like what we did a while ago, we will group it into two. So we'll have x cubed minus 5x squared for the first group and positive 3x minus 15 on the second group. Now our greatest common factor of the first group is x squared, and the greatest common factor of the second group is positive 3. And if we undo the distributive property or divide each term by the GCF, our first group will simply be x squared times x minus 5, and the second group will be positive 3 outside times x minus 5 inside. So this is now our factored form, which we can further simplify because x minus 5 is a common term for the first group and the second group. So our final answer will be x squared plus 3 times x minus 5. We can no longer factor out any of the terms because they're already the simplest form of the polynomial. So this is how we use the grouping technique in this polynomial. Now let's have another example. Now in this example, we will group it again into two, giving us x cubed plus 2x squared and negative 9x minus 18. The first group, our GCF is x squared, and the second group will give us a GCF of negative 9. Notice that I used negative 9 instead of 9 because one thing that you need to remember about factoring using GCF is you always want your leading term to be a positive term. So always get rid of the negative term or negative sign in your leading term or the first term by taking out the negative factor of that term. So if I have negative 9x minus 18, my GCF would be negative 9 because I want to get rid of the negative to my leading term. So once we factored it out, the first group is easy to factor. It will turn into x squared times x plus 2. And the second group of factors, since negative 9 is now outside, the term that is left inside the parentheses will be positive x plus 2 because you've took out the negative inside the big parentheses. Now you are left with the opposite sign of your term. So you have negative 9 outside and x plus 2 inside. So that means we can take out x plus 2 outside the parentheses and we are left with x squared minus 9 inside our big group. So this is now our factored form of the polynomial. However, we notice that the second or the first term, x squared minus 9, can still be factored out. We can still factor this out using the difference of two squares. So to completely factor out our polynomial, we'll use another factoring technique to further simplify our polynomial. So x squared minus 9 is simply x plus 3 and x minus 3. So the complete factored form of our polynomial is x plus 3 times x minus 3 times x plus 2. So once again, when you are factoring, you are not only limited to only one technique. Sometimes you need to use one or two techniques in factoring out a certain polynomial. So this is how we factor using, this is how we factor by grouping. And now we're going to be working on how to factor quadratic equation of the form ax squared plus bx plus c. Now for this particular quadratic equation, this one will be specific to a equal to 1, which means the coefficient of our leading term or x squared will be 1. Now what are some examples that has a quadratic equation with a leading coefficient of 1? An example of this quadratic equation or polynomial will be x squared plus 7x plus 12, or x squared plus 21x plus 20, or x squared minus 6x plus 8. All of them don't have a coefficient on the leading term because this one falls under this category. Now when this happens, we can factor out the quadratic equation using the technique that we're going to be using this time. So let's say we're factoring out x squared plus 7x plus 12. So the first thing that we're going to be doing is to draw a big X, and we'll use the last term, which is 12, and the middle term, which is 7, in our puzzle. So factoring quadratic equations similar to this one is like solving a puzzle, and you need to know your multiplication table once again to be able to complete the puzzle. Now, why is it a puzzle? Because what we're going to do next is to find the factor or factors of 12 that when you add them up will equal to 7. Now 12 has several factors or set of factors. We have 12 and 1, we have 3 and 4, and we have 6 and 2. Now all of them are factors of 12 because 12 times 1 is 12, 3 times 4 is 12, and 6 times 2 is 12. However, if you take the sum of the factors of these sets, the first set will equal to 13, the second set is 7, and the third set is 8. So notice that the middle term of our quadratic equation is 7, which means the pattern that we're looking for will only work for 3 and 4. So that means the number that we're looking for that will equal to 7 when we add them up will be 3 and 4. So the factored form of x squared plus 7x plus 12 is simply x plus 3 times x plus 4. So this is how we factor out quadratic equation of this form. Now if you want to check if your answer is correct, you can FOIL out x plus 3 times x plus 4, and you will see that this will equal to x squared plus 7x plus 12. However, if you use 12 and 1 and 6 and 2, it will not equal to the quadratic equation that we started from for this particular problem. That's why you need to make sure that you're choosing the right factor for the right middle term. So once again, your mastery of the multiplication table is extremely important to be able to factor out quadratic equations like this. So if you will need to use your multiplication table right next to you, use that to practice so you can start learning how to factor using the multiplication table. So let's answer some other examples of this quadratic equation. So just like what we did a while ago, we'll use 20, which is the last term, and use 21, which is the middle term, to find the factors of 20 that when you add them up will be equal to 21. And in this case, the factors of 20 could be 4 and 5, or 2 and 10, or 20 and 1. And in this case, 20 and 1 will fit the puzzle because 20 times 1 is 20, and 20 plus 1 is 21. So our factored form will be x plus 20 times x plus 1. And for example number 3, we'll have 8 as our last term and negative 6 for our middle term. So when this happens, we need to find the factors of positive 8 that will give you negative 6 when you add them up. And we know that the only time that we can have this pattern is when we multiply two negatives that will equal to positive and add two negatives which will equal to a negative number. So the factor that we're looking for here is negative 2 and negative 4. So x squared minus 6x plus 8 has a factor of x minus 2 times x minus 4. So once again, it's easier when we are factoring a quadratic equation when all the terms are positive. It will get a little bit challenging once you see a negative sign in either the middle term or the last term. That's why our next example will have a negative sign in the last term, which is negative 15. So we have negative 15, and we need to find the factors of negative 15 that will add up to 2. And those factors will be negative 3 and positive 5. So negative 3 times 5 is negative 15, and negative 3 plus 5 is 2. So it's safe to say that the most difficult part of this procedure is finding the numbers or factors that will match your middle term. So once you've found your matching factors, everything else is easy. So we have x minus 3 and x plus 5 as the factored form of our polynomial. And now the factoring techniques that we're going to be using in this quadratic equation will give us a leading term that is greater than 1. So now our a will be, or will be greater than 1, which means it could be 2 or 4 or 7 or 8. And when this happens, we'll be using several factoring techniques to solve for the factored form of this quadratics. We'll be using factoring by GCF, factoring by grouping, and we'll also be seeing a factoring technique that we used a while ago. So let's go ahead and see what are some examples of this quadratics that fall under this category. So if your leading term is greater than 1, that means you could have a quadratic equation similar to 3x squared plus 7x plus 3, or similar to these other two quadratic equations that you're seeing. So notice that the leading term of your quadratic term is no longer 1, but greater than 1. So let's go ahead and start the factoring technique for this particular problem. So we have 2x squared plus 5x plus 2. We're going to still see the x, or the big X, that we used from the previous factoring technique. But this time, we're not just going to use the last term. We're going to be using the product of the first term and the last term, and that will be the number that we're going to use to find the factor of 4 that will equal to 5 when you add them up. So we know that 2 times 2 is equal to 4, and the factors of 4 that gives you 5 when you add them up will be 1 and 4. So this is the added step that we're using whenever your quadratic equation falls under this category. So you multiply the product of the first term and the last term to find the matching factors of the middle term. Now, once we have found the matching factors, we're going to use an added step, and in this case, what we're going to do is we're going to copy the first term and the last term of the polynomial, or the original quadratic equation, and we will change the middle term using the new factored form of 4, which is 1 and 4. So our new polynomial will look something like this. So this is the added step that we're going to be using after we found the two factors. So notice that now we have 4-term polynomial, and when this happens, we can use factoring by grouping to be able to further factor this out. So now we have two groups that we can factor using GCF. So the factored form, or the greatest common factor of the first set, is 1x, and the greatest common factor of the second set is 2. So when we factor out 2x squared plus 1x, we'll have 2x plus 1 inside our first group, and 1x will be outside our first group. And for the second group, if we take out 2 from 4x plus 2, it will give us 2x plus 1 as a result. So notice that now we have a common factor of 2x plus 1, which we can separate and factor out. So our final factor will be 2x plus 1 times x plus 1, or 1x plus 2. So 1x plus 2 can further simplified, and we don't have to write the coefficient of 1 anymore, and simply write it as x plus 2. Now if you want to check if this is correct, just like what we did a while ago, just FOIL out 2x plus 1 and x plus 2, and it will equal to 2x squared plus 5x plus 2. So this is how we use this factoring technique when the leading term is no longer equal to 1. So let's go ahead and use another example for this type of quadratics. So now we have 2 and 7 to use, and 2 times 7 is equal to 14. And we need to find the factor of 14 that gives you 15 when you add them up. So obviously it's not going to be 7 times 4, because 7 times 4 is 14, but 7 plus 4 is not 15. So the factored form, or the factors of 14 that we're going to use, will be 14 and 1. So once we have our factors, we're going to use the first term, or copy the first term, and modify the middle term using 14x and 1x, and then copy 7 as our last term. And now that we have our two groups, we can use factoring by grouping to factor out the first group and the second group. The GCF for the first group is 2x, and the GCF for the second group is 1. So if we divide the first group by 2x, we are left with 1x plus 7. And if we divide 1x plus 7 by 1, it will simply be 1x plus 7. So our factored form will give us a common factor of 1x plus 7, which we can take out from the big group, leaving us with 2x plus 1 behind. So our factored form will be x plus 7 times 2x plus 1. And once again, I could say that the most complicated part of this procedure is finding the factors of the product of the first term and the last term. Now, sometimes it's easy to find, sometimes it could be challenging to find. That's why, once again, you need to know your multiplication table really well to be able to factor using this technique. Now, let's go ahead and answer the next one. We have 6x squared minus 23x plus 7. So we'll have the product of 6 and 7, which is 42, that will equal to negative 23 when you add them up. Now, notice that you will take a little bit longer to think of the two numbers that will match our pattern. And in this case, the factors that will equal to positive 42 when you multiply them and negative 23 when you add them up will be negative 21 and negative 2, because negative 21 times negative 2 is positive 42, and when you add them up it will equal to negative 23. So we're done with the difficult step. All we need to do is to repeat what we did a while ago and group them into two. Now the negative 2x should be inside the parentheses, so this one is a little bit of an error with my factoring or grouping. So we know that negative 2x is inside the parentheses plus 7. So the first group, we don't have any problem with that because the GCF of the first group is 3x. But the GCF of the second group, which is negative 2x plus 7, we always want to get rid of the leading term or the negative in the leading term. So the GCF should be equal to negative 1. So when you have a GCF of negative 1, if you divide negative 1 to negative 2x and positive 7, you will end up with 2x minus 7. So we'll have 3x times 2x minus 7 for the first group, and notice that the second group is supposed to be negative 1, will be negative 1 outside, and we'll have 2x minus 7 inside our second group. So 2x minus 7 is our greatest common factor, which we can take out. So our final answer will be 2x minus 7 times 3x minus 1. So this one, it took us a little while to find the factors of 42 that will equal to negative 23, because sometimes we'll encounter an easy number, sometimes we'll encounter a more complicated number like this one. Now let's have the next example. We have 7x squared minus 26x minus 8, and the product of 7 times negative 8 is negative 56. That when you add them up, or we're looking for factors of negative 56, that when you add them up will be equal to negative 26, which means our product should be a positive and a negative number, or the factor should be a positive and a negative number. So the factor or factors of negative 56 that we're looking for, again, it will take a while for some of you to think of those factors, but if you know your multiplication table really well, we're looking for negative 28 and positive 2 for the factors that gives you negative 26. And once again, the most difficult step in factoring this polynomial is finding the matching factors in our quadratic equation. But once you know or figure out the factored form or the factors that you're looking for, it will be easy after that. So we have 7x squared minus 28x plus 2x minus 8. By grouping, we'll have GCF of 7x for the first group and 2 for the second group. And by undoing the distributive property, the first group will give us 7x times 1x minus 4, and the second group will give us 2 times 1x minus 4. And 1x minus 4 is a common term, so the final answer will simply be x minus 4 times 7x plus 2. And these are the factoring techniques that we are going to use in algebra.